Oh. So good morning dear students. So we will start with the new chapter, that is what? Thermodynamics. So what is the meaning of thermodynamics and what content you are going to study in this chapter? Let us see one by one. So in the first one, here you are going to observe introduction part. So why or else what content you are going to observe in this chapter? Let us see. So thermodynamics in the sense, here thermodynamics in the sense, this is nothing but the process of what we observe as a transfer of heat energy. So here you are going to observe a process of a transfer of heat energy. Along with the process of a transfer of heat energy, one more, whatever the amount of heat energy, that is converting as a mechanical work here. So whatever the amount of heat energy you are providing here, that you are supposed to observe in the form of a mechanical work. So this content or is this process what we observe here, a transfer of heat energy, and what amount of heat energy you are provided here, that is converted as a mechanical work. So ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತಾರೆ, thermodynamics ಅಂತ ಹೇಳ್ತಾರೆ. So transfer of heat energy along with what here, heat energy ಏನು ಪ್ರೊವೈಡ್ ಮಾಡಿರ್ತೀರಿ ಅದು ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು thermodynamics ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. So this is a branch of physics which we observe as a transfer of heat energy as well as what here, along with the heat energy, this energy is converted as a mechanical work. Next, so which is called as a thermodynamic system. So before going to discuss about thermodynamics here, let us consider the basic terms related to the thermodynamics. What are the basic terms here? The first one, thermodynamic system. ಯಾವುದಕ್ಕೆ ನಾವು thermodynamic system ಅಂತ ಹೇಳ್ತೀರಿ? So it is nothing but a matter with a certain amount of, so it is a matter which is having a certain amount of what we can say quantity. So quantity, or else we are going to observe a certain amount of what here, a mass. So ಯಾವ ಒಂದು particular matter ಗೆ so certain quality ಇರುತ್ತಾ ಅಥವಾ certain identity ಇರೋದನ್ನ observe ಮಾಡ್ತೀರಿ. So it is having a certain kind of a identity and certain kind of what we consider a mass. ಅದಕ್ಕೆ ಆ particular matter ಗೆ ನಾವು ಏನಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ thermodynamic system ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. So certain quantity of matter which is having a particular identity as well as what here, a mass, that is what we consider as a thermodynamic system. Next, after getting a thermodynamic system here, now we are going to observe what is the meaning of a surroundings. ಯಾವುದಕ್ಕೆ ನಾವು surrounding ಅಂತ ಹೇಳ್ತೀರಿ? Let us assume this is what you are going to observe as a thermodynamic system here. So if you are going to observe this as a thermodynamic system, ಇದು ಒಂದು thermodynamic system ಅಂದಾಗ ಈ thermodynamic system ಏನ್ ಮಾಡುತ್ತಾ, outside this thermodynamic system, so outside again you are going to observe a particular matter. So particular ಒಂದು certain amount of matter na apart from the thermodynamic system, or else we can say outside of this thermodynamic system, what you are going to observe here, so that kind of a matter that we consider as a surroundings. ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀರಿ, surroundings ಅಂತ ಹೇಳ್ತಾರೆ. ಈ surrounding ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ so ಒಂದು particular condition. What is the condition here? So this thermodynamic system should interact. So this should compulsory what you should make here, interaction. Otherwise you are not going to say this as a surrounding of this particular thermodynamic system here. For example, if I consider one more thermodynamic system like this, ಇದೊಂದು thermodynamic system 2 ಅದಂತ assumption ಮಾಡೋಣ. ಈ thermodynamic system 2 ಏನಾದ್ರು ಈ particular matter ಜೊತೆಗೆ interact ಇರಲಿಲ್ಲ ಅಂದ್ರೆ, so there is no interaction, so ಇಲ್ಲಿ interaction ಇರಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಅವಾಗ ಏನಂತ ಹೇಳ್ತೀರಿ, so this matter or so this is not a surrounding of what here, a thermodynamic system 2. So system 2 ಏನಾಗಿಲ್ಲ, surrounding ಆಗಿಲ್ಲ, but system 1 ಏನಾಗುತ್ತೆ, surrounding ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ. ಯಾಕಂತಂದ್ರೆ thermodynamic system 1 ಏನ್ ಮಾಡಿದೆ, so this thermodynamic system 1 ಏನ್ ಮಾಡಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, interaction. So it is making a interaction with the matter. ಎಲ್ಲಿ interaction ಇರತ್ತಾ ಅಲ್ಲಿ ಮಾತ್ರ ನಾವೇನ್ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ, surrounding of a system ಅಥವಾ surrounding of a thermodynamic system ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. So compulsory, so thermodynamic system should interact with the surrounding which is we consider as a matter. ಆ ಮಧ್ಯಕ್ಕೆ ಮಾತ್ರ ನಾವೇನಂತ ಹೇಳ್ತೀರಿ, so that we consider as a surrounding here. So this is about the surrounding. Next, so which is called as a thermodynamic variables. ಯಾವುದಕ್ಕೆ ನಾವು thermodynamics variables ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ? Let us see. So here, if a thermodynamic system is there, so ಇದೊಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ thermodynamic system ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿರಂದ್ರೆ ಆ ಸಿಸ್ಟಮ್ ಯಾವ ಸ್ಟೇಟ್ ಒಳಗದ ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ so whether it is in a stable state or else whether it is in an unstable condition or else whether it is in a stable condition, ಆ ರೀತಿ ಆ ಸ್ಟೇಟ್ ಆಫ್ ಅ thermodynamic system ನ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ಕೆಲವೊಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್ ನ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. So what are those physical quantities? The first one we consider about the pressure, and the second one we consider about the volume, and the third one we consider about what here? A temperature, and the fourth one is very very important that we consider as a internal energy. So the fourth quantity which we are considered as a internal energy, and sometimes we observe as a work done. So ಕೆಲವೊಂದು conditions ಒಳಗೆ work done ಆಗಿದ್ದನ್ನು observe ಮಾಡ್ತೀವಿ. So these are the 5 very important physical quantities which represent a state of a thermodynamics. So that is the reason, so these kind of physical quantities only we call as a, so these kind of physical quantities only we call as what here? Thermodynamic variables. ಯಾಕಂತಂದ್ರೆ ಆ thermodynamic system ಅನ್ನ ಸ್ಟೇಟ್ ಹೇಳಬೇಕಂದ್ರೆ ಆ thermodynamic system ಅದ ಸ್ಟೇಟ್ ಹೇಳಬೇಕಂದ್ರೆ ಈ physical quantities ಡಿಸೈಡ್ ಮಾಡುತ್ತೆ. ಆ physical quantities ಯಾವುದು ಡಿಸೈಡ್ ಮಾಡುತ್ತೆ ಆ physical quantities ಗೆ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ thermodynamic variables. So that we consider as a thermodynamic variables here. Next, so what is the meaning of a thermodynamic process? ಯಾವುದಕ್ಕೆ ನಾವು thermodynamic process ಅಂತ ಹೇಳಿದ್ರಿ? Let us assume, so here you are going to observe pressure is also constant, and here you are going to observe volume is also remaining constant here, and there you are going to observe temperature also constant, again internal energy, and one more is work done, it will be remaining as a zero. So ಅಂದ್ರೆ ಕೆಲವೊಂದು physical quantities ಇದನ್ನ basically ಕೆಲವೊಂದು ಕಂಡೀಷನ್ ಒಳಗೆ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತಾರೆ. Apart from other conditions, following are pressure, volume, temperature, and one more is internal energy. So when we consider all these 4 factors as a constant, so whenever you are going to observe all these 4 as a constant, or else in turn we can say whenever you are going to observe a thermodynamic variables are remaining as a constant here. ಯಾವಾಗ ಆ thermodynamic variables constant ಅಂತ ಹೇಳ್ತೀರಿ ಅವಾಗ ಈ thermodynamic system ಏನಾಗಿದ್ದ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ ಒಳಗೆ ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. So this is thermodynamic system is under called as a stable condition. The reason is, so here you are going to observe all the thermodynamic variables remaining constant here. Whenever all the remaining constant here, there you are going to observe a thermodynamic system is under the condition called as what here? A stable condition. ಇದು stable condition ಅದ. ಇದರ ಒಳಗೆ ಯಾವುದಾದರೂ ಒಂದು physical quantity variation ಆಗಿದೆ ಅಂತ ತಿಳ್ಕೊಂಡು, let us assume pressure, volume, temperature, and one more is what here? Internal energy. So out of 4, any one physical quantity is changing with respect to time. So whenever it is changing with respect to time, if that is changing, there you are going to observe thermodynamic system will come into the condition called as what here? Unstable condition. ಯಾಕಂದ್ರೆ ಅದರೊಳಗಿರೋ ಥರ್ಮೋಡೈನಮಿಕ್ ವೇರಿಯಬಲ್ಸ್ ಚೇಂಜ್ ಆಗಿದೆ. ಅದರೊಳಗಿರೋ ವೇರಿಯಬಲ್ಸ್ ಚೇಂಜ್ ಆದಾಗ ಆ ಕಂಡೀಷನ್ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಆ ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ ಇರೋದು ಕನ್ವರ್ಟ್ ಆಗಿ ಆ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಏನಾಗಿರುತ್ತೆ ಅನ್ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಇಫ್ ಇಟ್ ಈಸ್ ಅನ್ಸ್ಟೇಬಲ್ ಕಂಡೀಷನ್, ನೌ ದಿಸ್ ಈಸ್ ವಿ ಕನ್ಸಿಡರ್ ಆಸ್ ಇಟ್ ಈಸ್ ಅಂಡರ್ ಅ ಪ್ರೊಸೆಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್. ಈಗ ಏನಾಗುತ್ತೆ ಒಂದು ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್ ಒಳಗೆ ಎಂಟರ್ ಆಗುತ್ತೆ. ಸೊ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೊಸೆಸ್ ಒಳಗೆ ಎಂಟರ್ ಆಗಿದೆ ಅಂತಂದ್ರೆ ಸೊ ಜಸ್ಟ್ ಯು to understand, so this thermodynamic system which was under called as a stable condition, now it is changing into the condition called as what here? Unstable. So stable condition ಇರೋದು unstable ಆಗೋ process ಗೆ ಅಥವಾ unstable ಆದ್ಮೇಲೆ ಬಂದಿರೋ ಒಂದು process ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ thermodynamic process here. So this we consider as a thermodynamic process. Next, after getting a thermodynamic process, now here you are going to observe what is the meaning of a thermodynamic equilibrium. ಯಾವುದಕ್ಕೆ ನಾವು thermodynamic equilibrium ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. Let us see. So if you are going to observe this as a thermodynamic equilibrium, so ಇದನ್ನ equilibrium ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ if this is a thermodynamic system, ಇದೊಂದು thermodynamic system ಅಂತ assumption ಮಾಡೋಣ. ಅದರೊಳಗೆ ಕೆಲವೊಂದು ಸರ್ಟನ್ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿ. So let us assume this as a point A and this will be taken as point B here, and this you are going to observe as a point C like this. Here you are going to observe many points. ಇದೊಂದು point D ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡೋಣ. Now at point A, what amount of temperature you are going to observe? That is given by a TA value. and the amount of temperature what you are going to observe at point B. So at point B, that will be given by a TB value, and similarly the amount of temperature what you are going to observe at point C, that will be given by TC, and this again fourth point given by point D. So ಎಲ್ಲ ಪಾಯಿಂಟ್ ಒಳಗೆ ಏನಾಗಿರಬೇಕಂದ್ರೆ ಕಂಪಲ್ಸರಿ temperature should remain constant at every point. So temperature should remain constant at every point in a thermodynamic system. ಆ thermodynamic system ಒಳಗೆ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ ಒಳಗೆ ಯಾವಾಗ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ, ಸೊ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ ಆ thermodynamic system ಯಾವ ಕಂಡೀಷನ್ ಒಳಗೆ ಅಂತ ಹೇಳ್ತಾರೆ, that is called as a thermal equilibrium condition. So that is under called as a thermal equilibrium condition. So thermal equilibrium condition in the sense at every point. So at every point temperature should remain constant in the thermodynamic system. So that we consider as a thermal equilibrium. Next, so what is the meaning of internal energy? So ಯಾವುದಕ್ಕೆ ನಾವು internal energy ಅಂತ ಹೇಳ್ತೀರಿ, ಆ internal energy ಒಳಗೆ ಕೆಲವೊಂದು ಟೈಪ್ಸ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. So what is the amount of internal energy corresponding to the ideal gas, and what is the amount of internal energy corresponding to what here real gas? Let us see. So when we observe for the ideal gas, so if I consider ideal gas and whenever we are going to observe real gas, so what is the difference between internal energy? Let us see. So when we observe here, so here you are going to observe ideal gas. ಯಾವಾಗ ideal gas ಅನ್ನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ, here we are going to observe all the molecules are having same amount of what here same amount of shape and same amount of what we consider as a size here. So ಎಲ್ಲ molecules ಗೆ size shape same ಇರೋದನ್ನ observe ಮಾಡ್ತೀರಿ, and all the molecules are moving in the condition called as what here random direction. So ಎಲ್ಲ molecules random direction ಒಳಗೆ ಮೂವ್ ಆಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. So in the kinetic theory of gases we studied about what here all the molecules are moving in a random direction. Here also the difference is here expectation. So expectation ಏನಾಗಿರುತ್ತೆ, so all the molecules may have the same amount of size or may not have the same amount of sizes. So but the condition all are moving in a random direction. So all are moving in a random direction, but here may or may not. So may or may not, they may have a same amount of size or is the same amount of what here shape. So that's what we are going to observe, may or may not of this shape as well as size. But the condition is what you are going to observe random direction. Apart from this random direction, one more property you are going to observe, that what we can consider intermolecular forces among the molecules. So there you are going to observe one more property in the real gases that will be considering as intermolecular forces among the molecules. ಇದ್ರೊಳಗೆ ಏನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ, ಎಲ್ಲಾ molecular same size same shape ಇರೋದಕ್ಕೆ intermolecular forces ನ negligible ಅಂತ ಹೇಳ್ತಾರೆ. So here you are going to observe intermolecular forces is negligible. negligible ಇರೋದಕ್ಕೆ ಇದರೊಳಗೆ ನೀವು ಯಾವಾಗ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀರಿ, ಆ ಟೆಂಪರೇಚರ್ ಪ್ರೊವೈಡ್ ಮಾಡೋದ್ರಿಂದ ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಏನ್ ಪ್ರೊವೈಡ್ ಮಾಡ್ದಂಗ ಆಗುತ್ತೆ, ಥರ್ಮಲ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀರಿ. ಆ ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡೋದಕ್ಕೆ ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಏನ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ. ಸೊ whenever this is what you are going to observe, so increase or is a change in the amount of kinetic energy, that only we consider as a internal energy corresponding to the ideal gas. So internal energy corresponding to the ideal gas, that is due to, so that is due to what here change in the amount of so change in the amount of what here kinetic energy of the molecules. But when we consider the real gases, here due to random direction again you are going to observe what here kinetic energy of the molecules, and due to what here intermolecular forces, there should be work done. So there should be work done to overcome this particular intermolecular forces here. So internal molecular forces ಏನು observe ಮಾಡ್ತೀರಿ, ಒಂದು molecule ಇನ್ನೊಂದು molecule ನಡುವೆ ಇರೋ intermolecular forces ಅನ್ನ ಬ್ರೇಕ್ ಅಪ್ ಮಾಡಬೇಕಂದ್ರೆ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಏನಾಗಿರುತ್ತೆ ಅಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಆಗಿರ್ತದೆ. ಅದಕ್ಕೆ ರಿಯಲ್ ಗ್ಯಾಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆ ರಿಯಲ್ ಗ್ಯಾಸ್ ಒಳಗೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಅಂತಂದ್ರೆ ಸೊ ದಟ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟು ವಾಟ್ ಹಿಯರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಸ್ ವೆಲ್ ಆಸ್ in order to overcome intermolecular forces there should be a certain amount of work done, that what we can consider as a internal energy. ಇಲ್ಲಿ internal energy ಅಂತ ಬಂದಾಗ kinetic energy ನು ಬರುತ್ತೆ, ಆ molecules ನಡುವೆ ಇರೋ intermolecular forces ನ ಅವಾಯ್ಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇನ್ನೊಂದು certain amount of work done observe ಮಾಡ್ತೀರಿ, ಅದನ್ನು ನಾವು ಇಲ್ಲಿ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. ಅದಕ್ಕೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಸ್ ವೆಲ್ ಆಸ್ ವಾಟ್ ಹಿಯರ್ ವರ್ಕ್ ಡನ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಟು ದ ರಿಯಲ್ ಗ್ಯಾಸ್. ಬಟ್ ಯಾವಾಗ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅನ್ನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಓನ್ಲಿ ದ ಕ್ವಾಂಟಿಟಿ ಗಿವನ್ ಬೈ kinetic energy. So this is the differences when we observe for what here internal energy corresponding to the ideal gas and the corresponding to real gases. Next, so after getting internal energy, now you are going to discuss about the zeroth law of thermodynamics. So what is the meaning of a zeroth law of what here thermodynamics? ಯಾವುದಕ್ಕೆ ನಾವು zeroth law ಅಂತ ಹೇಳ್ತೀರಿ? Let us assume. So ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? So here I am going to consider the two systems. So let us assume this is, we can consider system A, and one more we are going to observe system B. So this is, we are going to observe system B. Now system A is in thermal equilibrium with the system C. So let us assume here you are going to observe system A is in thermal equilibrium with the system C. Similarly, when we observe here system B, so now the system B is again a thermal equilibrium. So it is under called as a thermal equilibrium with the system C. So in consideration ಮಾಡ್ತೀರಿ two systems. So two systems are in thermal equilibrium. So two systems are in a thermal equilibrium with the another system. So two systems are in what here thermal equilibrium with the another system separately. So separate ಆಗಿದೆ. So ಅಲ್ಲಿ ಒಂದಕ್ಕೊಂದು ಜಾಯಿಂಟ್ ಇಲ್ಲ. So there you are going to observe two systems, system A and system B are in thermal equilibrium with the third system separately. Then the two systems are in thermal equilibrium with each other. So this is what we defined as a zeroth law. ಅಂದ್ರೆ ಏನು? So system A ಅನ್ನೋದು system C ಗೆ equilibrium ಆಗಿದೆ, system B ಅನ್ನೋದು ಮತ್ತೆ system C ಗೆ equilibrium ಇದೆ, ಬಟ್ ಸಪರೇಟ್ ಇದೆ. ಸೊ ಸಪರೇಟ್ ಆಗಿ ಒಂದಕ್ಕೊಂದು equilibrium ಇತ್ತಂದ್ರೆ ಸಿಸ್ಟಮ್ ಎ ಮತ್ತೆ ಸಿಸ್ಟಮ್ ಬಿ ನು ಏನಾಗಿರುತ್ತೆ ಥರ್ಮಲಿ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಇರುತ್ತೆ ಅನ್ನೋದು zeroth law of thermodynamics ನ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. So this is we consider as a zeroth law of what we can consider thermodynamics. So when we define two systems are in thermally equilibrium with the third system separately, then these two systems are in thermal equilibrium with each other. So this is a definition. Next, after getting a zeroth law of thermodynamics, now you are supposed to observe what is the meaning of a first law of thermodynamics. ಯಾವುದಕ್ಕೆ ನಾವು first law of thermodynamics ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Now here you are going to observe, so we are going to consider certain amount of heat energy you are provided to the system. So ಒಂದು thermodynamic system ಗೆ ಒಂದು certain amount of heat energy provide ಮಾಡೋದು ಅಂತ assumption ಮಾಡು. So certain amount of heat energy provide ಮಾಡತ್ರಿ, a certain amount of heat energy provide ಮಾಡಿದಾಗ, so there you are going to observe a change in the amount of heat energy that is given by a dq value. So already ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿ, so ಯಾವಾಗ ನೀವು heat energy ನ provide ಮಾಡ್ತೀರಿ, ಸೊ ಪ್ರೊವೈಡೆಡ್ ಹೀಟ್ ಎನರ್ಜಿ ಅದರೊಳಗೆ ಪಾರ್ಟ್ ಅನ್ನ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಿ, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ. ಯಾಕಂದ್ರೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಅಂತಂದ್ರೆ ಸೊ ದೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್ ಇನ್ ದ ಅಮೌಂಟ್ ಆಫ್ ವಾಟ್ ಹಿಯರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ಯಾವ ರೀತಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ಸೊ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಅ ಚೇಂಜ್ ಇನ್ ದ ಅಮೌಂಟ್ ಆಫ್ ವಾಟ್ ಹಿಯರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಯಾಕೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಅದ್ರೊಳಗೆ ಏನ್ ಚೇಂಜ್ ಆಗಿದೆ, ಈಗ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಏನ್ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ, ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀರಿ. ಸೊ ವೆನ್ ವಿ ಪ್ರೊವೈಡ್ extra amount of heat energy, there is a change in the quantity given by thermal energy. So thermal energy change ಆಗಬೇಕಂದ್ರೆ ಏನು extra amount of ಏನು provide ಮಾಡ್ತೀರಿ, temperature ನ provide ಮಾಡ್ತೀರಿ. So if I provide the extra amount of temperature, there is a change in the thermal energy. So due to change in the thermal energy, there is a increase in the velocity of the molecules. When there is a increase in the velocity of the molecules, there is a change in the amount of what we can say kinetic energy. Whenever there is a change in the amount of kinetic energy, there is a entirely change in the quantity of what here internal energy. So that's what, so provided amount of heat energy first is used for internal energy. ನೀವೇನ್ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡುತ್ತೀರಿ, ಆ ಪ್ರೊವೈಡ್ ಮಾಡಿರೋದ್ರೊಳಗೆ ಒಂದು ಪಾರ್ಟ್ ನ, ಸೊ ಒಂದು ಪಾರ್ಟ್ ಆಫ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿನ ಸೊ ಫಸ್ಟ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಗಿ ಯೂಸ್ ಮಾಡೋದಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಆಗಿ ಯೂಸ್ ಮಾಡಿರೋದು. Next, so remaining, so what amount of energy remained there, that remained amount of that will be work done. So remained amount of energy is used for the, so used for the work done here. ಅಂದ್ರೆ ಏನು, ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀರಿ ಅದ್ರೊಳಗೆ ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿನ ಹೀಟ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀರಿ. ರಿಮೈನಿಂಗ್ ಇರೋದನ್ನ, ಸೊ ರಿಮೈನಿಂಗ್ ಇರೋದನ್ನ ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸಸ್ ಅನ್ನ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಳತ್ತ. ಇಂಟರ್ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸಸ್ ನ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡೋದಂತಂದ್ರೆ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಅಲ್ಲಿ ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಆಗಿರುತ್ತೆ. ಅದಕ್ಕೆ ಏನ್ ಬರೀತೀರಿ, ಸೊ ಟೋಟಲ್ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಏನ್ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ, ಸೊ ಪಾರ್ಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಯೂಸ್ಡ್ ಫಾರ್ ದ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ and the remaining used for what here, work done in the system. So that's what we can write, dq is equal to, so dq is equal to du. Next, so work done ಅನ್ನು ಯಾವ ರೀತಿ ಬರೀಬಹುದು ಅಂತಂದ್ರೆ, so work done that will be given by what here, force into displacement. So it's the basic definition. ಈಗ ಏನ್ ಬರೀತೀರಿ, force can be taken as pressure multiplied by area, again multiplied by displacement. Now pressure as usual, area multiplied by displacement, that can be taken as what here, a volume. So volume ಏನಾಗಿದೆ change ಆಗಿರೋದನ್ನ ಬರೀತೀರಿ, so that will be given by delta V. So that's the reason, so work done that is replaced by pressure multiplied by what we can write here, delta V. So change in the amount of volume here. So this is what we are going to observe, thermodynamics first law ಅಥವಾ first law of thermodynamics ಅಂತ ಹೇಳ್ತಾರೆ. So I will define here the amount of heat energy provided. So amount of heat energy provided to the thermodynamic system is equal to, so is equal to what here, a part of energy for the internal energy as well as the amount of remained energy as a work done. So this is the definition when we observe for the first law of a thermodynamics. ಇದಕ್ಕೆ ನಾವು ಏನು ಹೇಳ್ತೀರಿ, first law of a thermodynamics ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Next, so after getting first law of thermodynamics, now here you are going to observe what are the applications of this first law of thermodynamics. So applications anta bandaga, the first process that we consider as a isothermal. So the first application of this particular first law of thermodynamics, that is given by isothermal process. ಯಾವುದಕ್ಕೆ ನಾವು isothermal process ಅಂತ ಹೇಳಿದ್ರಿ, which is called as a isothermal. So remember, iso in the sense there you are going to observe same, so whichever, so ಯಾವುದೇ ಕ್ವಾಂಟಿಟಿಯಲ್ಲಿ ಐಸೋ ಅಂದಾಗ ಕ್ವಾಂಟಿಟಿ ಸೇಮ್ ಅನ್ನೋದನ್ನು ಮೀನಿಂಗ್ ಕೊಡ್ತದೆ, ಸೊ ಅಥವಾ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತಾದ್ರೂ ಹೇಳ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ಥರ್ಮಲ್, ಸೊ ಥರ್ಮಲ್ ಇನ್ ದ ಸೆನ್ಸ್ ದೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ temperature. So here whenever the process takes place under the constant amount of temperature, that process we consider as what here, isothermal process. ಆ process ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀರಿ, isothermal process ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. So isothermal, remember here you are going to observe a same amount of ಅಥವಾ constant amount of temperature. ಯಾವ constant amount of temperature ಒಳಗೆ ಯಾವ process ಆಗಿರುತ್ತೆ ಆ process ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀರಿ, isothermal process ಅಂತ ಹೇಳ್ತೀವಿ. Let us see. So here you are going to observe first law of thermodynamics equation, that is given by dq is equal to, so dq is equal to du plus what we can write here, work done. So this is what we are going to observe as a first law of thermodynamics. ಇದರೊಳಗೆ ಈಗ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ, ಸೊ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂದ್ರೆ, ಸೊ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಥರ್ಮಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗ್ತದೆ. ಸೊ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆ ಅಂತಂದ್ರೆ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆ ಅಂತಂದ್ರೆ ಏನು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಯಾವಾಗ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯ್ತು ಅಂದ್ರೆ, ಸೊ ಚೇಂಜ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ, ಸೊ ಚೇಂಜ್ ಇನ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ವ್ಯಾಲ್ಯೂ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಝೀರೋ. ಯಾಕಂದ್ರೆ ಇದು ಯಾವುದು ಚೇಂಜ್ ಆಗಿಲ್ಲ. ಸೊ ಯು ವ್ಯಾಲ್ಯೂ ಬಿಫೋರ್ ಅಂಡ್ ಯು ವ್ಯಾಲ್ಯೂ ಆಫ್ಟರ್ ದ ಪ್ರೊಸೆಸ್ ರಿಮೇನ್ಸ್ ಸೇಮ್. ಯಾಕಂತಂದ್ರೆ ಯು ವ್ಯಾಲ್ಯೂ ಯಾಕೆ ಬಿಫೋರ್ ಆಫ್ಟರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತಂದ್ರೆ ಇಲ್ಲಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ. ಯಾಕೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ ಅಂತಂದ್ರೆ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ. ಯಾವಾಗ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತಂದ್ರೆ ಅದರೊಳಗಿರೋ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ. ಯಾಕೆ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ ಅಂತಂದ್ರೆ ಅದರೊಳಗಿರೋ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಎಂಟೈರ್ ಪ್ರೊಸೆಸ್ ಅಂದ್ರೆ, ಸೊ ಹಿಯರ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ, ದಟ್ ಎಂಟೈರ್ entirely depends on the temperature properly. So it is entirely depending only on the temperature. So that is the reason. So here what amount of change in the internal energy, that will be taken as a zero. So internal energy change agilla. So how the internal energy change agilla. So du value should be taken as what here? Zero. So for du value is zero, what you are going to observe? dw is equal to what we can write? W value. So andre ಒಂದು ಸಿಸ್ಟಮ್ ಅದ ಈಗ. ಸೊ ಸಿಸ್ಟಮ್ ಒಳಗೆ ಏನ್ ಮೀನಿಂಗ್ ಕೊಡುತ್ತಾ, ಐಸೋಥರ್ಮಲ್ ಪ್ರೊಸೆಸ್ ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನ್ ಕೊಡುತ್ತಂದ್ರೆ ನೀವು ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ. ಸೊ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ. ಸೊ ಕ್ಯೂ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ. ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೀರಿ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ? ವರ್ಕ್ ಡನ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿರಿ ಅಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡತ್ತೀರಿ? ವರ್ಕ್ ಡನ್ ಆ ಸಿಸ್ಟಮ್ ದಿಂದ ಆಗಿದ್ದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಅಥವಾ ಇನ್ನೊಂದು ಮೀನಿಂಗ್ ಒಳಗೂ ಹೇಳ್ತೀವಿ. ಸೊ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಸೇ, ವಾಟ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್. ಸೊ ಆ ಸಿಸ್ಟಮ್ ದಿಂದ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಆಗಿರುತ್ತೆ ಅಷ್ಟೇ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಏನಾಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಇಲ್ಲಿ ಲಿಬರೇಟ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ ವಾಟ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಹ್ಯಾಸ್ ಬಿನ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್, ದ ಸೇಮ್ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ದಟ್ ಹ್ಯಾಸ್ ಬಿನ್ liberated here. So here what you are going to observe, what amount of heat energy absorbed by the system or is given to the system. So what amount of heat energy absorbed by the system or is what amount of heat energy provided to the system, the same amount of work done by the system here. Adrinda same amount of ಏನು observe ಮಾಡ್ತೀರಿ? work done ಆಗಿದ್ದನ್ನ observe ಮಾಡ್ತೀರಿ. So this is we consider as a isothermal process. So this is a very very important process here. Now, so after getting isothermal process, so isothermal ಅಂತಂದ್ರೆ just you have to remember what amount of energy, what amount of heat energy were provided, the same amount of work has been done there. Next, the second application that we consider as a adiabatic process here. ಯಾವುದಕ್ಕೆ ನಾವು adiabatic process ಅಂತ ಹೇಳ್ತೀರಿ? So which is called as a adiabatic process. Now, so in order to say adiabatic process here, remember if this is a thermodynamic system here, ಇದೊಂದು thermodynamic system ಅದಂತ assumption ಮಾಡೋಣ. Okay, so here if we consider this as a thermodynamic system, ಈ ಸಿಸ್ಟಮಿಗೆ ಯಾವುದು ಎನರ್ಜಿ ನಾವು ಅಬ್ಸಾರ್ವ್ ಆಗಂಗಿಲ್ಲ, ಯಾವುದು ಎನರ್ಜಿ ಲಿಬರೇಟ್ ಆಗಿಲ್ಲ. ಅಂದ್ರೆ ಯಾವುದು ಎನರ್ಜಿ ನಾವು ಪ್ರೊವೈಡ್ ಮಾಡಿಲ್ಲ ಅಥವಾ ಯಾವುದು ಎನರ್ಜಿ ಸಿಸ್ಟಮ್ ನಿಂದ ಎಕ್ಸಿಟ್ ಆಗಿಲ್ಲ. ಸೊ ನೋ ಎನರ್ಜಿ ಇಸ್ ಅಲೋಡ್ ಟು ಎಂಟರ್ ನಾರ್ ಎಕ್ಸಿಟಿಂಗ್ ಹಿಯರ್. ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್, ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ದ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ. ಸೊ ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ದ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ. ಅಂದ್ರೆ ಯಾವುದು ಹೀಟ್ ಎನರ್ಜಿನ ಅಲೋ ಮಾಡಿಲ್ಲ. ಸೊ ನೈದರ್ ಹೀಟ್ ಎನರ್ಜಿ ಅಲೋಡ್, ಸೊ ನೈದರ್ ಹೀಟ್ ಎನರ್ಜಿ ಅಲೋಡ್ nor this has been liberated. So no heat energy allowed and not this will be liberated here. So neither or not. So ಯಾವುದು ನಾವು ಇನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಲ್ಲ, ಹೀಟ್ ಎನರ್ಜಿ ಎಂಟರ್ ಆಗಿಲ್ಲ, ಯಾವುದು ಹೀಟ್ ಎನರ್ಜಿ ಎಕ್ಸಿಟ್ ಆಗಿಲ್ಲ ಆ ಸಿಸ್ಟಮ್ ದಿಂದ. ಈ ರೀತಿ ಪ್ರೊಸೆಸ್ ಇದ್ರೆ ಆ ಪ್ರೊಸೆಸ್ ಗೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರೊಸೆಸ್. ಸೊ ಈ ರೀತಿ ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರೊಸೆಸ್ ಆದ್ರೆ ಆ ಸಿಸ್ಟಮ್ ಏನಾಗುತ್ತೆ, ಅದರೊಳಗೆ ಏನೇನು ಚೇಂಜಸ್ ಆಗುತ್ತೆ ನೋಡೋಣ. ಸೊ ಯಾಕಂದ್ರೆ ಯಾವುದೇ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಪ್ರೊವೈಡ್ ಮಾಡಿಲ್ಲ, ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿಲ್ಲ ಅಂದಾಗ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ಲೂಡ್ ಆಗುತ್ತೆ, ಪ್ರೆಷರ್ ಇನ್ಕ್ಲೂಡ್ ಆಗುತ್ತೆ, ವಾಲ್ಯೂಮ್ ಇನ್ಕ್ಲೂಡ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. ಸೊ ಬಿಕಾಸ್ ದ ರೀಸನ್ ಇಸ್ ವಾಟ್ ಹಿಯರ್, ಟೆಂಪರೇಚರ್ ಇಸ್ ರಿಮೈನಿಂಗ್ ಆಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಹೇಳಿ ಬರಂಗಿಲ್ಲ. ಯಾಕಂತಂದ್ರೆ ನೀವು ಯಾವುದು ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿಲ್ಲ, ಬಟ್ ಇಂಟರ್ನಲಿ ಟೆಂಪರೇಚರ್ ಏನಾಗಬಹುದು, ವೇರಿಯೇಷನ್ ಆಗೋ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇರುತ್ತೆ. ಸೊ ಲೆಟ್ ಅಸ್ ರೀಡ್. ಸೊ when we observe here dq is equal to, we can write du plus what we can write here w value. So this is the equation. So equation ಈ ರೀತಿ ಬರೆದಾಗ now dq value, so here dq value is going to become as what here 0. ಯಾಕಂದ್ರೆ ಯಾವುದೇ ಹೀಟ್ ಎನರ್ಜಿ ಎಂಟರ್ ಆಗಿಲ್ಲ, ಯಾವುದೇ ಹೀಟ್ ಎನರ್ಜಿ ಲಿಬರೇಟ್ ಆಗಿಲ್ಲ. ಸೊ dq value should be taken as 0 here. If dq is 0, we can write dw is equal to what here minus w, ಅಥವಾ ಈ ರೀತಿನೂ ಬರೀಬಹುದು. So minus du is equal to what here w value. So these are the two conditions here. So conditions ಏನು, so here work done can be taken as a positive. ಇಲ್ಲಿ work done ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡತ್ರಿ, ಪಾಸಿಟಿವ್ ಬಂದಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡತ್ರಿ. ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಏನಾಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, ನೆಗೆಟಿವ್ ಇರೋದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಬಟ್ ಈ ಮೇಲ್ಗಡೆ ಕೇಸ್ ಒಳಗೆ, ಫಸ್ಟ್ ಕೇಸ್ ಒಳಗೆ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡತ್ರಿ, ವರ್ಕ್ ಡನ್ ಇಟ್ ವಿಲ್ ಬಿ ನೆಗೆಟಿವ್, ವೇರ್ ಆಸ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಯು ಆರ್ ಸಪೋಸ್ ಟು ಅಬ್ಸರ್ವ್ ಆಸ್ ಅ ಪಾಸಿಟಿವ್. ಸೊ ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು, ಸೊ ಈಗ ಯಾವುದು ಸಿಸ್ಟಮ್ಗೆ ಯಾವುದೇ ಎಕ್ಸ್ಟ್ರಾ ಅಮೌಂಟ್ ಆಫ್ ಹೀಟ್ ಎನರ್ಜಿ ಪ್ರೊವೈಡ್ ಮಾಡಿಲ್ಲ ಅಥವಾ ಲಿಬರೇಟ್ ಆಗಿಲ್ಲ ಅಂದಾಗ ಇದ್ರೊಳಗೆ ಆ ಸಿಸ್ಟಮ್ ದಿಂದಾನೇ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಏನಾಗಿದೆ ಈಗ ಈ ಸಿಸ್ಟಮ್ ದಿಂದಾನೇ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಆಗಿದೆ ಅಂತ ಅಸಂಪ್ಷನ್ ಮಾಡೋಣ. ಸೊ ಹಿಯರ್ ವರ್ಕ್ ಈಸ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್. ಸೊ ವೆನೆವರ್ ವರ್ಕ್ ಈಸ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್ ದೇರ್ ವಿ ಕನ್ಸಿಡರ್ ವರ್ಕ್ ಡನ್ ಆಸ್ ಅ ಪಾಸಿಟಿವ್. ಯಾವಾಗ ಆ ಸಿಸ್ಟಮ್ ನಿಂದಾನೇ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಆಗಿರತ್ತೆ ಅದನ್ನೇನ್ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ work done, that will be taken as a positive. If work is done on the system, ಆ ಸಿಸ್ಟಮ್ ಮೇಲೆ ನಾವು ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ವರ್ಕ್ ಆಗಿದ್ದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ that we consider as a work done as a negative. ಸೊ ಆ ಸಿಸ್ಟಮ್ ಮೇಲೆ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀರಿ, ಫೋರ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ಆ ಸಿಸ್ಟಮ್ ದಿಂದ ಒಂದು ವರ್ಕ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ that we consider as a work done on the system. Here we consider work done by the system. So work done by the system ಇದ್ದಾಗ ಇದರಿಂದಾನೇ ಸಡನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಆಗಿತ್ತಂದ್ರೆ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಇದರ ಒಳಗೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ವರ್ಕ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್ ಇದ್ದಾಗ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ರೆಡ್ಯೂಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಟೆಂಪರೇಚರ್ ಶುಡ್ ವಾಟ್ ಇಯರ್ ಡಿಕ್ರೀಸಸ್. ಯಾಕಂದ್ರೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ದಟ್ ಈಸ್ ಡಿಸೈಡೆಡ್ ಬೈ ದ ಕ್ವಾಂಟಿಟಿ ಆರ್ ಇಟ್ಸ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಗಿವನ್ ಬೈ ವಾಟ್ ಇಯರ್ ಟೆಂಪರೇಚರ್. ನೆಕ್ಸ್ಟ್ ಇಫ್ ಇಟ್ ಈಸ್ ವರ್ಕ್ ಡನ್ ಆನ್ ದ ಸಿಸ್ಟಮ್, ಈಗ ಸಿಸ್ಟಮ್ ಮೇಲೆ ಒಂದು ಸರ್ಟನ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಆಗಿತ್ತಂದ್ರೆ ಅದು ಆಗ್ಬೇಕಂದ್ರೆ ಇನ್ನೇನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕು. ಇಂಟರ್ನಲ್ ಎನರ್ಜಿನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಟೆಂಪರೇಚರ್. ಸೊ ಟೆಂಪರೇಚರ್ ಏನ್ ಮಾಡ್ತೀರಿ ಬೇಸಿಕ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ. ಯಾವಾಗ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸ್ ಆದಾಗ ಅದರದ ಒಳಗೆ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ವರ್ಕ್ ಡನ್ ಆನ್ ದ ಸಿಸ್ಟಮ್ ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ ವರ್ಕ್ ಡನ್ ಬೈ ದ ಸಿಸ್ಟಮ್ ಇತ್ತಂದ್ರೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ರೆಡ್ಯೂಸ್ ಆಗಂತಂದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ಏನು ರೆಡ್ಯೂಸ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ ಟೆಂಪರೇಚರ್ ರೆಡ್ಯೂಸ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಕ್ವಾಂಟಿಟೀಸ್ ವೆನ್ ವಿ ಅಬ್ಸರ್ವ್ ರಿಗಾರ್ಡಿಂಗ್ ವಾಟ್ ಇಯರ್ ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರೋಸೆಸ್. ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರೋಸೆಸ್ ಅಂದ್ರೆ ನೆನ್ಪಿಟ್ಟು so all the physical quantities there you are going to observe keep on varying. Only the thing is what here dq, no amount of heat energy is entering, no amount of heat energy is liberating. So this is the conditions when we observe regarding what here adiabatic processes. Next, after getting adiabatic processes, now you are going to observe what is the meaning of a cyclic process. ಯಾವುದಕ್ಕೆ ನಾವು cyclic process ಅಂತ ಹೇಳ್ತೀವಿ, which is called as a cyclic process. So cyclic process ಅಂತ ಹೇಳಬೇಕಂದ್ರೆ so here the condition is what it may go through the any number of a thermodynamic process. ಸೊ ಈಗ ಇಲ್ಲಿ ಏನ್ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿರಿ ಆ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಅನ್ನೋದ ಸೊ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೋಸೆಸ್ ಒಳಗಾದ್ರೂ ಮೂವ್ ಆಗ್ಲಿ. ಸೊ ಹಿಯರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸಿಡರ್ ಅ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್. ಆ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಏನಾಗಿರುತ್ತೆ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ ಪ್ರೋಸೆಸ್ ಒಳಗೂ ಹೋದ್ರೂ ಲಾಸ್ಟಿಗೆ ಏನ್ ಬರಬೇಕು ಇನಿಷಿಯಲ್ ಸ್ಟೇಟಿಗೆ ರಿಟರ್ನ್ ಆಗಬೇಕು. ಸೊ ಇಟ್ ಶುಡ್ ರಿಟರ್ನ್ ಇನ್ ಟು ವಾಟ್ ಇಯರ್ ಇನಿಷಿಯಲ್ ಸ್ಟೇಟ್ ಆಫ್ thermodynamics. It may go under what here many number of thermodynamic processes. Even though it is under many number of thermodynamic processes, there you are going to observe it should return back into what we consider as a initial state. So initial state ಗೆ ರಿಟರ್ನ್ ಆದಾಗ ಆ process ಗೆ ನಾವು ಏನಂತ ಹೇಳಿದ್ರಿ cyclic process. That should be considered as a cyclic process. Next, so after getting a cyclic process, now the fourth application of this first law of thermodynamics that will be taken as a isochoric process. So which is called as a isochoric process. ಯಾವುದಕ್ಕೆ ನಾವು isochoric process ಅಂತ ಹೇಳ್ತೀರಿ. So which we consider as a isochoric. So choric in the sense, remember here we are going to keep a volume as a constant. So we are going to observe a volume as a constant here. So ಇಲ್ಲಿ observe ಮಾಡ್ತೀರಿ volume constant ಇರೋದನ್ನು observe ಮಾಡ್ತೀರಿ. So whenever volume remains constant here, so that kind of a process that we consider as a isochoric. ಅದಕ್ಕೆ ನಾವು isochoric ಅಂತ ಹೇಳ್ತೀವಿ. So change in the other thermodynamic variables with respect to what here a constant amount of the volume. So let us write. So now the first equation you are going to write. So dq is equal to du plus what we can write here work done. So work done ಈ ರೀತಿ equation ಬರೀತೀರಿ. In that one, again we can write, so dq is equal to, so dq is equal to what we can write here, du plus p multiplied by delta v. So delta v ಅಂತಂದ್ರೆ change in the amount of what we can say volume. So ಇಲ್ಲಿ volume ಅನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟಿರಿ ಅಂದಾಗ delta v value should be taken as what here 0. So delta v value completely 0 ಆಗುತ್ತೆ. So delta v value 0 ಆಯ್ತಂದ್ರೆ so dq is equal to what we can write here du. So what is the meaning of this one? So when we observe, so this meaning here, there you are supposed to observe a thermodynamic system. ಇದೊಂದು thermodynamic system ಅದಂತ assumption ಮಾಡು. So if this is a thermodynamic system here, for this thermodynamic system you are going to provide a certain amount of heat energy. So ಏನೋ ಒಂದು certain amount of heat energy ನ provide ಮಾಡ್ತೀರಿ. So ಯಾವಾಗ ಒಂದು certain amount of heat energy provide ಮಾಡಿರಿ, ಆ provide ಮಾಡಿರೋ heat energy ನ complete ಆಗಿ ಅದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದಂದ್ರೆ it is using only for the internal energy, not for what your work done. So this process takes place when we consider what your isochloric. So isochloric ಅಂದ್ರೆ ಎಷ್ಟು amount of heat energy provide ಮಾಡ್ತೀರಿ ಎಲ್ಲಾನು ಇದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದಂದ್ರೆ internal energy ಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So now if you are going to observe a certain amount of heat energy that has been liberated, ಈ ಸಿಸ್ಟಮ್ ದಿಂದ ಒಂದು certain amount of heat energy liberate ಆಗಿತ್ತಂದ್ರೆ, so ಯಾವಾಗ liberate ಆಗಿತ್ತಂದ್ರೆ ಎಷ್ಟು amount of internal energy change ಆಗಿರುತ್ತೆ ಅಷ್ಟೇ amount of ಏನು observe ಮಾಡ್ತೀರಿ heat energy liberate ಆಗಿದ್ದು observe ಮಾಡ್ತೀರಿ. So this is the case when we observe here the same amount of liberated amount of heat energy that will be equals to what here reduced amount of internal energy. ಎಷ್ಟು amount of temperature reduce ಆಗುತ್ತೆ ಅಷ್ಟು amount of internal energy reduce ಆಗುತ್ತೆ, ಎಷ್ಟು amount of internal energy reduce ಆಗುತ್ತೆ ಅಷ್ಟು amount of ಏನು observe ಮಾಡ್ತೀರಿ heat energy liberate ಆಗಿದ್ದನ್ನ observe ಮಾಡ್ತೀರಿ. So this process that we observe as a isochloric process. ಇದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀರಿ isochloric process ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. So it's about the isochloric process here. Next, so again one of the important application of this first law of thermodynamics that we consider as a isobaric process. So which is called as a isobaric process. So isobaric, so iso ಅಂತಂದ್ರೆ ಆಲ್ರೆಡಿ ಮತ್ತೆ ಏನು ಹೇಳಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ, ಬಾರಿಕ್ ಅಂದಾಗ so isobaric ಅಂದಾಗ so which should be keep as a constant here. So which should be keep as a constant here, there you are going to keep the pressure as a constant. So there you are going to keep pressure as a constant term here. So ಯಾವಾಗ pressure ನ constant ಇಡ್ತೀರಿ, again you are going to observe the equation given by dq is equal to du plus what we can write here work done. So this is the equation. In that one dq, so dq again there you are going to observe dq is equal to du plus so work done that can be taken as what here a change in the amount of volume with respect to certain amount of pressure. So p into delta v ಅಂತ ಬರೀತೀರಿ. In that one, so pressure is kept constant. ಅದಕ್ಕೆ so specific heat capacity, so specific heat capacity at constant pressure. So at constant pressure for a given change in the amount of temperature. So for a given change in the amount of temperature, that can be written as like Cp is going to represent what here a specific heat capacity at constant pressure. Next, so du, so du that can be taken as what here specific heat capacity at a constant volume. So that will be Cv plus Cv multiplied by dt. Next, so there you are going to observe. So now we can write. So equation ಬರೀತೀರಂದ್ರೆ R multiplied by dt. ಯಾಕಂತಂದ್ರೆ so ideal gas equation that we have taken as what here. So P into delta V. So P into delta V that will be taken as nR multiplied by dt. So change in the amount of temperature makes change in the amount of volume. So according to the Boyle's law. So now if you are going to observe this is the equation, so this will get cancelled here. So after making a cancellation terms, so we can write Cp is equal to Cv plus R, or else we can write Cp divided by Cv. So Cp divided by Cv minus 1 that will be equals to what here R divided by Cv. So just you are going to divide by the Cv term. Next Cp divided by Cv. So Cp divided by Cv that will be taken as a ratio that ratio as a gamma. So gamma is equal to Cp divided by Cv. Now we can write so gamma minus 1. So gamma minus 1 that will be equals to what here? R divided by Cv. So this is the equation. So this equation what we are going to observe here, or else this equation can also be written like this. Idana equation in baribodu andre so Cv is equal to R divided by gamma minus 1. So R divided by gamma minus 1. So this is the entire process when we observe for the isobaric process. Complete agi observe ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಈ isobaric process ಒಳಗೆ ಈ ರೀತಿ ಆಗಿದ್ದನ್ನು observe ಮಾಡಿ. So this is about what we observe as a so the first one application, the first application isothermal process, second application adiabatic process, third one is cyclic process, fourth one is isochoric process, and the fourth one is what here? Isobaric process. These are the 5 important process which takes place as a applications of a first law of thermodynamics. ಇದನ್ನ ಏನು observe ಮಾಡ್ತಾರೆ? First law of thermodynamics 5 applications ಇರೋದನ್ನ ಈ ರೀತಿ observe ಮಾಡ್ತಾರೆ. Next, so now we have to identify what is the amount of work done. So what is the amount of a work done if I consider the isothermal process and if I consider what here? Adiabatic process. Adiabatic process ಅನ್ನು consideration ಮಾಡಿದ್ರೆ ಎಷ್ಟು amount of work done observe ಮಾಡ್ತೀರಿ. ಅದೇ ರೀತಿ so isothermal process ಅನ್ನು consideration ಮಾಡಿದ್ರೆ so what amount of work done you are going to observe here. Let us see. So the first here you are going to observe work done by. So work done by isothermal process. So first I will go through the isothermal process here. So isothermal process iddaga theoretically equation in baritri. So what are the theoretical equation for the work done when we observe for the isothermal process? So again the isothermal in the sense remember there you are going to observe temperature should remain what here? Constant. So ಇಲ್ಲಿ temperature ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ constant ಇರೋದನ್ನ observe ಮಾಡ್ತೀವಿ. So this is the condition isothermal. So isothermal ಅಂದ್ರೆ temperature should remain what here? Constant. Now work done. So work done ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. So isothermal process ಇದ್ದಾಗ equation ಬರೆದಿದ್ದು ನಾವು. So what is the equation there? There you are going to observe equation. ಅಲ್ಲಿ equation ನ ಬರೆಯೋಕ್ಕಿಂತ ಮುಂಚೆ so now we will consider a cylinder like this. So let us assume this is a cylinder here and this is a bottom of a cylinder. So this we consider as a bottom of a cylinder and this we consider as a piston. ಇದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತಾರೆ? Piston of a cylinder. So this is we consider as a piston of a cylinder which should be non-conducting. So which should be what here? A non-conducting. ಅಂದ್ರೆ ಆ thermodynamic system ಮತ್ತೆ surrounding ನಡುವೆ interaction ನ ಸ್ಟಾಪ್ ಮಾಡ್ತದೆ. ಸೊ ಇದೇನಾಗುತ್ತೆ ಇಲ್ಲಿ thermodynamic system. So this is what here thermodynamic system here and this is what here surrounding. ಆ surrounding ಮತ್ತೆ thermodynamic system ನಡುವೆ ಏನು ಸ್ಟಾಪ್ ಮಾಡೋದು ಅಂತಂದ್ರೆ so this is interaction ಅನ್ನ ಸ್ಟಾಪ್ ಮಾಡ್ಲಿಕ್ಕೆ ಒಂದು piston ಅನ್ನ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡಿರಿ. ಆ piston ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ? ನಾನ್ ಕಂಡಕ್ಟಿಂಗ್. Now again this is what we observe as a walls of a container. So walls of a container again that should be what here? Non conducting. So ಅದನ್ನು ಏನು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀರಿ? ನಾನ್ ಕಂಡಕ್ಟಿಂಗ್ ಇರೋದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. Next, after getting here, this we consider as a perfectly conducting bottom. So perfectly conducting bottom of a cylinder. So perfectly conducting a bottom of a cylinder here. Cylinder consideration ಮಾಡಿರಿ. So bottom in observe ಮಾಡಿರಿ. So bottom of a cylinder that should be perfectly conducting. Now, so if I may, so this is a change in the amount of a let us assume here you are going to observe position as a A point. ಇದನ್ನ piston in consider ಮಾಡಿರಿ. ಒಂದು particular initial position A point ಒಳಗದಂತ assumption ಮಾಡೋಣ. Now this is shifted into the particular position like this. ಈ ರೀತಿ ಒಂದು position ಅನ್ನು change ಮಾಡ್ತಾರೆ. Now we are going to observe final position of this piston that will be given by B value. ಎಷ್ಟು amount of position change ಆಗಿದೆ ಅಂತ ಇದಕ್ಕೆ so ಎಷ್ಟು amount of position change ಆಗಿದೆ observe ಮಾಡ್ತಾರೆ that will be given by dx. So dx is change in the position of a piston. Now the piston what we observe here this is having a particular amount of area. So particular amount of area that is given by the A. So particular amount of area that will be given by A here. So ಈಗ ಅಲ್ಲಿ small amount of work done ಆಗಿದ್ದು observe ಮಾಡ್ತೀವಿ. So small amount of work done ಏನು ಬರೀತೀರಿ? dw. So this small amount of work done that will be force into displacement. So force into displacement ಆ displacement ಏನು ಬರ್ದಿರಿ? dx ಫಾರ್ಮೆಟ್ ಒಳಗೆ ಬರೀತೀರಿ. Next again dw it will be equals to force ನ ಯಾವ ರೀತಿ ಬರೀತೀರಿ pressure multiplied by area. So pressure multiplied by area again multiplied by what we can say displacement. Next pressure multiplied by area into displacement. So totally what we can write here dw is equal to, so dw ಅಂದಾಗ initially in observe ಮಾಡಿರಿ. So initially the total amount of volume that was given by v1. Now the volume what we observe here that will be given by v2. So v2 amount of volume change ಆಗಿದ್ದು observe ಮಾಡಿರಿ. Initially v1 ಅದ next in observe ಮಾಡಿರಿ v2. It may increase, it may decrease here. So that what we can write p multiplied by, so p multiplied by, now we can write this as a delta v. So this is what we observe as a delta v. Now we have to identify what is the amount of a total work done. So total work done from which point to which point here. So ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಚೇಂಜ್ ಆಗಿದೆ ವಾಲ್ಯೂಮ್ v1 ಇಂದ ವಾಲ್ಯೂಮ್ ಏನು ಚೇಂಜ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, v2 ಚೇಂಜ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ. ಇದರೊಳಗೆ ಏನು ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟಿರಿ, ಟೆಂಪರೇಚರ್ should remain constant here. When the temperature is constant, the volume which is changing from, so which is changing from v1 into what here v2 value. So that is given by dw. Now in that one if it is a dw, so there you are going to observe so amount of work done, so amount of work done that we are going to observe by the equation like this. So again ಬರೀತೀರಿ w is equal to integrating from v1 to v2 and dw that will be taken as what here p multiplied by dv. So p multiplied by dv ಅಂದ್ರೆ small amount of change in the volume. So now there you are going to observe w is equal to integrating from v1 to v2. Now according to ideal gas equation PV is equal to what we can write here nRT. So this is the equation nRT equation ಬರೀತೀರಿ in that one. So there you are going to observe P is equal to ಅಥವಾ P divided by ಅಥವಾ ಇಲ್ಲ ಏನು ಬರೀಬಹುದು ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ so we are going to replace the P value. So P value ನ replace ಮಾಡಿ ಬರೆದಾಗ so P divided by nRT. So V is equal to ಅಥವಾ so there you are going to observe the equation given by, so equation ಬರೀತೀರಿ P is equal to, so P is equal to RT ಅಥವಾ nRT divided by V value. So this is the equation what we can write here. So P is equal to nRT divided by V value. In that one, so P is replaced here nRT. So nRT divided by V value multiplied by dV. So now again the equation there you are going to observe integrating. So integrating ಮಾಡುವಾಗ ಯಾವುದೇ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ ಔಟ್ಸೈಡ್ ಬರೀತೀವಿ. So n is number of moles here. So that can be taken as constant. R will be remaining as a constant and temperature is also constant ಯಾಕಂದ್ರೆ isothermal process ಅದ. Next remaining is v1 to v2. So integrating from v1 to v2 1 divided by v multiplied by what we can write here dv value. In that one w is equal to, so w is equal to nRT. Next 1 divided by v, so 1 divided by v that can be taken as log of e. So log of base e with respect to what we can write here v2 minus v1. So this is v2 minus v1. So again w is equal to, so w is equal to nRT. So nRT log to the base e v2 divided by v1. So v2 divided by v1. So log to the base e ಇರೋದನ್ನ log to the base 10 ಬರೆದಾಗ so 2.303. So 2.303 nRT log to the base 10. Again we can write v2 divided by v1. So this is the amount of work done. So entirely the equation what you have written here, this is the amount of work done during the isothermal process. So isothermal process ಒಳಗೆ equation observe ಮಾಡಿ. So very very important equation, so just need to remember. Next, so after getting work done in ಅಥವಾ work done by isothermal process ಆದ್ಮೇಲೆ next one here you are going to observe work done. So work done in adiabatic process. So adiabatic process ಒಳಗೆ ಯಾವ ರೀತಿ work done ಆಗಿದೆನೋ observe ಮಾಡ್ತೀವಿ. Let us see. So work done in adiabatic process. So adiabatic process ಒಳಗೆ ಯಾವ ರೀತಿ work done ಆಗಿದ್ದು observe ಮಾಡ್ತೀರಿ and what is the final equation corresponding to what here work done when we observe the adiabatic process. So adiabatic process andre again we have to remember there is no entering amount of what here heat energy, there is no amount of liberation of what here heat energy. So ಯಾವುದು amount of heat energy enter ಆಗಿಲ್ಲ, ಯಾವುದು amount of heat energy liberate ಆಗಿಲ್ಲ. So that what we have taken dq should be 0. So dq value should be what here? 0. So if dq value is 0, again we have the equation that is given by dq is equal to du plus what you have taken there, amount of work done w. So then in dq value is 0 agata. Now w is equal to minus what we can write here, du value. So minus du value. In that one, again there you are going to observe. So ಈಗ work done ಅನ್ನು calculate ಮಾಡುವಾಗ the equation ಬರ್ದಿದ್ರಿ. So what was the equation there? So Cp multiplied by dt. So Cp multiplied by dt. So Cp multiplied by dt, that will be equals to what here? Cv multiplied by dt plus, so plus what you have taken here? R into dt. So this was the equation. Athwa direct ಆಗಿ ಬರೀತಿದ್ರಿ Cp minus Cv is equal to what taken there? R value. So ಅದರ ಒಳಗೆ ಈ ಟರ್ಮ್ 0 ಆಗ್ತದೆ, ಯಾಕಂದ್ರೆ dq value 0 ಅಂದಾಗ Cp and in terms of dt, this value is going to become as a 0. So if it is 0, now here you are going to observe small amount of work done. Now a total amount of work done that can be taken as integrating from. So integrating of a small amount of work done. So small amount of work done from where to where. ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ changes ಆಗಿದ್ದನ್ನು observe ಮಾಡ್ತಾರೆ. Adiabatic process ಅದ. So adiabatic process ಅಂದಾಗ temperature is not a remaining constant here. So temperature is changing from T1 to T2. When the temperature is changing from T1 to T2, again there you are going to observe the equation W is equal to, so W is equal to what we can write here? T1 to T2. Now the dW. So now the dW that will be taken as what here? Cv multiplied by dt. So this is the equation. ಯಾಕಂದ್ರೆ Cp ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ 0 ಇರೋದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ Cv multiplied by dt. Again the equation in that one, so specific heat capacity at constant value that will be remaining constant here, and integrating from T1 to T2. So T1 to T2 multiplied by dt. So this is the equation. Again, so on making a further values, there you are going to observe W is equal to, so W is equal to what here? Cv, next integration of dt, that will be T2 minus T1. So T2 minus T1, here the negative term. So negative irodonna observe ಮಾಡ್ತೇವೆ, because here we have taken minus du, so this will be negative, and here also it should be negative. Next, so that we can write, so W is equal to, so W is equal to Cv multiplied by T1 minus T2. So T1 minus T2. So this is the equation. Further on simplification, ಇದನ್ನ further simplification ಮಾಡಿ ಬರೆದಾಗ, so Cv value already we have taken, Cv is equal to what here? R divided by gamma minus 1. So this was the equation. ಈ equation ಒಳಗೆ consideration ಮಾಡಿದ್ರೆ, so when we replace here, again W is equal to, so W is equal to NR ಅಂತ ಅವರು consideration ಮಾಡ್ತಾರೆ, ಅಥವಾ simply we can write NR or only R here. So NR divided by gamma minus 1, again multiplied by T1 minus T2. So T1 minus T2. So this is the equation corresponding to what here? Amount of work done. So amount of work done when we consider the adiabatic processes. Complete ಆಗಿ adiabatic process ನ consideration ಮಾಡಿದಾಗ, so this is the equation. So you have to remember this also, this equation. So very very important equations here. So work done by isothermal process and work done by adiabatic processes here. So these are the two important equations related to these two particular processes here. Next, so based on this, again you are going to observe particular PV diagrams. So what is the meaning of a PV diagram? ಯಾವುದಕ್ಕೆ ನಾವು PV diagram ಅಂತ ಹೇಳ್ತೀರಿ, which is called as a PV diagram. Okay, so here PV diagrams. So what are the meaning of a PV diagrams? So PV diagrams in the sense pressure along the y-axis and volume along the x-axis. So you are going to consider pressure and volume along these two axes like this. In that one, the first process what we observed there, isothermal. So isothermal andaga temperature only remains constant, whereas so here PV diagrams. So when we discuss about the PV diagrams, we have taken about the isothermal process. So in that one, temperature is remaining constant, so that you are going to observe this is a curve corresponding to the isothermal process. and the second one adiabatic. So adiabatic andaga temperature, volume, pressure mooru change agutta. So that's what you are going to observe. This is the second graph corresponding to the adiabatic process here. Now the third process, when we observe isochoric. So isochoric andaga volume constant ittirtare, and this is a graph corresponding to what here isochoric process. And the fourth one isobaric. So isobaric andaga so pressure remains constant here. So when we keep the pressure as constant, this is what we observe as the isobaric process. So this is regarding what we observe as a PV diagrams. So illen observe ಮಾಡ್ತೀರಿ. So PV diagrams ಅನ್ನು ಇರೋದನ್ನ observe ಮಾಡಿ. Next, so after getting PV diagrams, very important application in this chapter that we observe as a Carnot engine. So Carnot engine, how it works here and on which process it is going to work here, everything we are going to observe one by one steps. So the first step here, the step one we consider as a isothermal expansion. ಇದಕ್ಕೆ ನಾವು ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಂತ ಹೇಳ್ತಾರೆ isothermal expansion ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. Now here you are going to observe as a cylinder and it is having a piston at a position of x1. So x1 position ಒಳಗೆ ಒಂದು piston ಅನ್ನು observe ಮಾಡಿರಿ. When it is at a position of x1 here, it is having a volume given by v1. Now expansion. So expansion ಅಂತಂದ್ರೆ piston ಏನ್ ಮಾಡ್ತಾರೆ little bit ಈ ರೀತಿ movement ಮಾಡ್ತಾರೆ. So when we make a expansion here, now it is shifted into a particular position given by x2. So when it is shifted here, now the volume what we observed as a v1, it is changing into what here v2. So whenever volume changes, again the pressure also changes, that is changing from where p1 into p2 value. Whereas the isothermal, the process what we observe isothermal, so that the temperature remains constant. ಯಾಕಂದ್ರೆ isothermal ಅಂತ ಯೂಸ್ ಮಾಡಿರಿ, isothermal ಒಳಗೆ pressure ಅನ್ನ temperature ನ ಏನ್ ಮಾಡ್ತಾರೆ constant term ಇರೋದನ್ನ observe ಮಾಡ್ತೀವಿ. So that's the reason so T1 temperature remains T1 only, whereas pressure is changing from P1 into what here P2 value, whereas volume is changing from where V1 into V2 value. So whenever we have the isothermal process, there you are going to observe change in the internal energy, it will be zero. ಯಾಕಂದ್ರೆ temperature constant ಆಗುತ್ತೆ, temperature constant ಅಂದಾಗ internal energy constant ಆಗುತ್ತೆ. So change in internal energy already observe ಮಾಡಿ. So du value should be taken as a zero. So now dq is equal to dw. So ಇದು equation ಒಳಗೆ according to the first law of thermodynamics, we observe dq is equal to dw. So now we will identify total amount of work done, which is changing from a volume of V1 into what here V2. So V1 to V2 in ಎಷ್ಟು amount of work done ಆಗಿರುತ್ತೆ, ಎಷ್ಟು amount of heat energy provide ಮಾಡಿರೋ heat energy ದಿಂದ ಎಷ್ಟು amount of work done obtain ಆಗಿದೆ ಆ equation ನ substitute ಮಾಡ್ತಾರೆ. So you are integrating from V1 to V2. Now the work done, so small amount of work done P into dV value. So ಇದನ್ನ total simplify ಮಾಡಿದಾಗ work done in isothermal process. In the previous content only we discussed as a work done in isothermal process. ಆ equation ಬರೆದಾಗ nRT, so nRT log to the base E V1 divided by V2 ಅಥವಾ V2 divided by V1 ನ process observe ಮಾಡಿ. So when we consider isothermal process, work done in isothermal process ಒಳಗೆ equation ಬರೆದ್ರಿ, so log to the base ಇರೋದನ್ನ log to the base ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಿನೂ ಬರೀಬಹುದು. So 2.303 you are multiplying here. So this is the first process or the first step in the Carnot engine. So Carnot engine ಒಳಗೆ ಇದು was the first process ಅಥವಾ first step ನ ಈ ರೀತಿ observe ಮಾಡಿರಿ. Next, the second step, when we observe here, the second step is called as a adiabatic expansion. ಈ ರೀತಿ ಫಸ್ಟ್ ಏನ್ ಮಾಡಿರಿ, x1 ಪೊಸಿಷನ್ ಇರೋದನ್ನ x2 ಪೊಸಿಷನ್ ಗೆ ಮೂವ್ ಮಾಡ್ತೀರಿ, ಪಿಸ್ಟನ್ ಅನ್ನ ಮೂವ್ ಮಾಡುವಾಗ isothermal expansion observe ಮಾಡ್ತೀರಿ. Next process, again you are going to shifting a piston from, so piston x1 ಇತ್ತು, x2 ಬಂದದ, x2 ದಿಂದ ಮತ್ತೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡುತ್ತೀರಿ, x3 ಪೊಸಿಷನ್ ಗೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ತೀರಿ. So when we move through the x3 position, again, so volume was V2. So previously in the first step it was V1, it was changing into V2. Now the volume is changing into what here? V2 into V3. So V2 into what here? V3. Similarly, the pressure is also changing from P2 into what here? P3 value. So now adiabatic, ali adiabatic iddaga temperature constant agangilla, temperature constant irlarde adu ಏನು ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಸೊ T1 ಟರ್ಮ್ ದಿಂದ T2 ಟೆಂಪರೇಚರ್ ಗೆ ಚೇಂಜ್ ಆಗಿದ್ದು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. ಸೊ ನಾವು ಅಡಿಯಾಬೆಟಿಕ್ ಅಂದಾಗ there is no enter of heat energy, there is no liberation of heat energy. ಅದಕ್ಕೆ dq ವ್ಯಾಲ್ಯೂ ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ, 0 ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ. ಇಲ್ಲಿ ಐಸೋಥರ್ಮಲ್ ಇರೋದಕ್ಕೆ ಟೆಂಪರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇತ್ತು, ಇಂಟರ್ನಲ್ energy 0 ತಗೊಂಡಿದೆ. So here dq value should be 0. So if dq value 0, again according to the equation dq value 0 ಆಯ್ತು ಅಂದ್ರೆ so we have taken dw is equal to minus du. So dw is equal to what here? Minus du. So ಅದರೊಳಗೆ minus du ಅಥವಾ du is equal to minus dw ಬರೀತೀರಿ. So dw value is what here? P into dv value. So that total equation that again work done in case of what here? Adiabatic process. ಅದರೊಳಗೆ ಏನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿರಿ ಅದೇ ರೀತಿಯಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತೀರಿ. So final equation is given by nr divided by gamma minus 1 multiplied by T1 minus T2. So this is about the second step. So after getting a second step, now so x1 position, x2 position, again it is shifting into what here? x3 position. ಈಗ x3 ಮತ್ತೆ ಇಲ್ಲಿ compress ಮಾಡ್ತೀರಿ. So compressing. So what we observe here, engine is compressed from x3 position into what here? x4 position like this. ಈ ರೀತಿ compression ಆಗ್ತದೆ. So first it was expanded and now it is compressed here. So when we are going to expansion, there you are going to observe isothermally, thereafter you are going to observe adiabatically. Now it is compressing through the isothermal and thereafter it is compressing through what here? Adiabatic. So yavaga isothermal ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀನಿ, again the previous temperature. So ಇಲ್ಲಿ T2 ಇತ್ತು, ಯಾಕಂದ್ರೆ previous step ಒಳಗೆ ಇಲ್ಲಿ temperature T2 ಇರುತ್ತೆ, ಇನ್ನು ನೀನು observe ಮಾಡ್ತೀರಿ same amount of temperature T2 ಇರೋದನ್ನ observe ಮಾಡ್ತೀರಿ. Next, the pressure what we are going to observe here, that is changing from P3 into what here? P4. So pressure P3 ಇಂದ P4 change ಆಗಿದ್ದು observe ಮಾಡಿರಿ. Again similarly volume is changing from what here? V3 into V4. So again the volume is also keep on changing. So isothermal ಇರೋದಕ್ಕೆ internal change in the amount of internal energy 0 ತಗೋತೀರಿ. So now we have W3 is equal to Q2. ಇಲ್ಲಿ Q2 ಬರೆಯಂಗಿಲ್ಲ, ಯಾಕಂತಂದ್ರೆ dq value 0 ಇರುತ್ತೆ, neither heat energy is entering nor liberating. ಅದಕ್ಕೆ Q2 amount of work done ಈ process ಒಳಗೆ ಆಗಿದ್ದು observe ಮಾಡ್ತೀರಿ. compression ಇರೋದಕ್ಕೆ work done ಏನು observe ಮಾಡ್ತೀರಿ? negative, because work is done on the system. ಇಲ್ಲಿ work is done on the system ಅದ, ಇದು ಎರಡು process ಒಳಗೆ ಏನು observe ಮಾಡಿರಿ? work is done by the system ಇದೆ. So that is the reason we can write minus Q2. So again the equation nr. Now the temperature in this process, ಈ process ಒಳಗೆ ಆ temperature ಏನು observe ಮಾಡಿರಿ? third step ಒಳಗೆ ಟೆಂಪರೇಚರ್ T2 ಇರೋದಕ್ಕೆ ಇಲ್ಲಿ T2 ಬರೀತೀರಿ. ಸೊ T2 ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ log of e to the V3 divided by V4. ಯಾಕಂತಂದ್ರೆ ಐಸೋಥರ್ಮಲ್ ಅದ, ಸೊ ವರ್ಕ್ ಡನ್ ಇನ್ ಐಸೋಥರ್ಮಲ್ ಪ್ರೋಸೆಸ್ ಇಕ್ವೇಶನ್ ಆಲ್ರೆಡಿ ಪ್ರೀವಿಯಸ್ ಕಂಟೆಂಟ್ ಒಳಗೆ ಡಿರೈವ್ ಮಾಡಿರಿ. ಸೊ ದ ಸೇಮ್ ಇಕ್ವೇಶನ್ ಯು ಆರ್ ರೈಟಿಂಗ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿ ವಾಲ್ಯೂಮ್ಸ್ ಹಿಯರ್. Next, the last step, there you are going to observe. So when we observe the last step here, so there you are going to observe adiabatic compression. So ಇಲ್ಲಿ ಏನು observe ಮಾಡ್ತೀರಿ? adiabatic compression ಇರೋದನ್ನು observe ಮಾಡಿ. So adiabatic compression ಅಂದ್ರೆ ಮತ್ತೆ ಫರ್ದರ್ ಏನ್ ಮಾಡ್ತೀರಿ? x4 ಪೊಸಿಷನ್ ಇಂದ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಏನಿತ್ತು x1 ಇತ್ತು. ಸೊ x1 ಪೊಸಿಷನ್ ಗೆ ಇದೇನಾಗಿದ್ದು observe ಮಾಡಿರಿ? ಕಾಂಪ್ರೆಸ್ ಆಗಿದ್ದು observe ಮಾಡ್ತೀವಿ. ಸೊ ಯಾವಾಗ adiabatic ಇರುತ್ತೆ, ಸೆಕೆಂಡ್ dq value 0. when we have dq value 0, adiabatic ಅಂದಾಗ ಟೆಂಪರೇಚರ್ it should not remain constant here, so that it is changing from T2 into what here? T1. So T2 ದಿಂದ T1 ಗೆ ವೇರಿಯೇಷನ್ ಆಗಿದ್ದು observe ಮಾಡಿರಿ. Now the pressure is changing from what here? P4 into P1, and the volume is changing from where? V4 into original volume given by V1 here. So again you are going to observe adiabatic expansion, adiabatic compression, so that we can observe a total amount of work done nr divided by gamma minus 1, again multiplied by what here? T1 minus T2. So this is the steps what you are going to observe in the Carnot engine. So Carnot engines ಒಳಗೆ ಈ 4 steps ಇರೋದನ್ನು observe ಮಾಡಿ. The first one internal isothermal expansion, adiabatic expansion, next compression, that is followed by isothermal as well as adiabatic. So first expansion ಆಗುತ್ತೆ, next compression ಆಗಿದ್ದನ್ನು observe ಮಾಡಿ. So these are the four important equations. There you are going to observe by four different steps here. So four different steps within the four equations obtain ಆಗಿದ್ದು observe ಮಾಡಿ. So this is a W1 equation and this is what we observe as a W2 equation. So the W2 equation ಬರೀತೀರಿ and here we observe as a W3 equation in the work done, that will be in the third process, W4 in the sense work done in the fourth process. So this is the fourth step here. So these are the four steps what we obtain a different equations in these four steps here. Now there you are going to observe adding. So total ಎಷ್ಟು work done ಆಗಿದೆ, so Carnot engine ದಿಂದ a total ಎಷ್ಟು work done ಆಗಿದನ್ನು observe ಮಾಡೋಣ. So in order to identify a total amount of work done, that we can observe W is equal to W1 plus W2 ಯಾಕಂದ್ರೆ expansion ಅದ. So work done by the system ಇದ್ದಾಗ work done in consideration ಮಾಡಿರಿ, positive consideration ಮಾಡ್ತೀರಿ. Next work done in the case that will be compression. So compression ಇದ್ದಾಗ work done on the system ಇರುತ್ತೆ, on the system ಇರೋದಕ್ಕೆ work done negative ನ consideration ಮಾಡ್ತಾರೆ. Again the fourth step work done that will be negative. The reason is compression. So compression in the sense work done on the system. So that's what we can write a total amount of work done that will be equals to what here, W1 plus W2 minus W3 and minus W4. Just observe these four equations. ಇಲ್ಲೇ four equations ಅದ. ಈ ರೀತಿ equations ಒಳಗೆ W2 and one more is what here, W4. These two will get cancelled. So after getting these two will get cancelled here, there you are going to observe. So W1, so W1, sorry, not a W1, a W2. So W2 and W4. So these two will get cancelled here. After getting these two will get cancelled. Now we can write nRT1. So nRT1 log to the base E. Thereafter V2 divided by V1. So it's the first W1 equation. And W3, so that is given by nRT2. So nRT2 and log of to the base E. So log of to the base E. Thereafter we can write V3 divided by V4. So this is a total equation or is a total amount of work done in case of a Carnot engine. So in the case of what here, a Carnot engine. So this is a total amount of what we observe as a work done. Now this is similarity equals to, so now we will plot the graph. So when we plot the graph here, what kind of the process you are going to observe, let us see. The same steps what we observe here, that we are going to represent in the form of a graph. Let us see. So when we represent in the form of a graph here, there you are supposed to observe. So there you are supposed to observe, initially the pressure was P1 and the volume was V1 and the temperature was T1. Now the first step what we have taken here, this was a isothermal expansion. Isothermal andaga temperature constant ittu, so that we can write a T1 here. Now the pressure is changing P1 to what here, P2 value, because the volume is changing what here, V1 into what here, V2 value. So this is what we observe as a isothermal expansion. So this is the process where we observe as a isothermal expansion, or as simply we can write step 1. So the step 1 process. Next, in the second step, there you are going to observe adiabatic expansion. So adiabatic expansion in the sense pressure was changing P2 into P3, and now the volume is changing V2 into V3. Now the temperature is also changing from T1 into what here, T2. So this we consider as a step 2. So this is a step 2 in the sense adiabatic expansion. Next, the third step when we observe here, that is given by, now the pressure, this will be changing from P3 into what here, P4, and the volume is changing from V3 into what here, V4. Now the temperature is changing. Whether it is changing or not, it is keeping constant. ಯಾಕಂತಂದ್ರೆ ಅಲ್ಲಿ isothermal compression consideration ಮಾಡಿರಿ. When we consider the third step here, isothermal compression, temperature remains same. So temperature remains same. That's what we can observe isothermal expansion, sorry, compression. Thereafter adiabatic compression. So adiabatic compression, there you are going to observe pressure P1, it is going into what here, P1, and the volume what we observe V4 is changing into what here, V1, and the temperature T2, it was changing into what here, T1. So because this process is what here, adiabatic compression. So adiabatic compression. So when we observe here, let us give the certain points. So this is the point A, and this will be point B, and this will be point C, and this what we observe as a point D. Now the equation what we obtain here, so this equation is nothing but total amount of area. So total amount of area, that is ABCD. So that is what we observe as a, ಇಲ್ಲಿ ಎಷ್ಟು amount of work done ಆಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನ 4 steps ಒಳಗೆ representation ಮಾಡ್ತೀರಿ. ಆ 4 steps ಅನ್ನ graphically ನಾವು ಈ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, ಅಥವಾ theoretically equation ಪ್ರಕಾರ ಈ ರೀತಿ ನಾವು total amount of work done ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವ. So this is the total amount of work done in case of what here, Carnot engine. So Carnot engine ಒಳಗೆ theoretically ಇಷ್ಟ amount of work done ಆಗಿರುತ್ತೆ. So graphically identification ಮಾಡಿದಾಗ, so work done that will be equals to what here, area under ABCD. So area under ABCD, this is the amount of work done that will be graphically, and those two are the equation corresponding to the formatically. Next, so thereafter the last content of this chapter that will be taken as a efficiency of a Carnot engine. So what is the meaning of a efficiency of a Carnot engine? ಯಾವದಕ್ಕೆ ನಾವು efficiency ಅಂತ ಹೇಳ್ತೀರಿ, which is called as a efficiency of what here, Carnot engine. Now efficiency ಅಂದ್ರೇನು, ನೀವು ಎಷ್ಟು ಇನ್ಪುಟ್ ಕೊಡ್ತೀರಿ, ಸೊ ಎಷ್ಟು ಇನ್ಪುಟ್ ಕೊಟ್ಟಾಗ ಎಷ್ಟು ಔಟ್ಪುಟ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ ಎಷ್ಟು ಇನ್ಪುಟ್ ಕೊಟ್ಟಿರಿ, ಎಷ್ಟು ಔಟ್ಪುಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡತ್ರಿ, ಅದರದ್ದು ಎಫಿಷಿಯನ್ಸಿ ಅಂದ್ರೆ ಅದರ ಕೆಪಾಸಿಟಿ. ಸೊ ದಟ್ ವಿ ಕನ್ಸಿಡರ್ ಆಸ್ ಅ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ಅ Carnot engine. Now what amount of input you are providing? So what amount of input providing here, that net amount of heat energy that will be given by what here, Q1. So Q1 is the net amount of what we can say amount of heat energy provided to the Carnot engine. Now what amount of output you are going to observe here? So ಎಷ್ಟು ಔಟ್ಪುಟ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ, so what amount of work this will make, ಎಷ್ಟು amount of work ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ, ಅಷ್ಟು amount of ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, ವರ್ಕ್ ಆಗಿದ್ದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. So that is what we can say efficiency. In order to identify the efficiency, we have the notation given by neta. So neta is equal to, so what amount of work has been done by the what amount of heat energy provided. So what amount of work has been done by the what amount of heat energy provided, that we consider as a efficiency. Now neta is equal to, so work done ಎಷ್ಟಾಗಿರುತ್ತೆ ಅಂದ್ರೆ Q1 minus Q2. So Q1 minus Q2 divided by, again we can write this as a Q1, or else neta is equal to 1 minus Q2 divided by Q1. So this is what we can say efficiency of a Carnot engine. So this equation can also be written as, ಇದನ್ನ equation ಒಂದು ಬೇರೆ ರೀತಿನೂ ಬರೀಬಹುದು, ಯಾಕಂದ್ರೆ Q2 value and one more we calculate what there, Q1 value. So already previous steps ಒಳಗೆ Q1 ನ Q2 calculate ಮಾಡಿರಿ. So when we observe Q2, so Q2 in the sense there you are going to observe adiabatic, so adiabatic compression, sorry not adiabatic, isothermal compression. So ಇದನ್ನ ಯಾವ ರೀತಿ ಬರೀಬಹುದು ಅಂತಂದ್ರೆ, so neta is equal to 1 minus Q2 divided by Q1 ಅಂತಂದ್ರೆ, so there you are going to observe isothermal. So isothermal, so this is what here, isothermal compression. So isothermal compression divided by isothermal expansion. So isothermal expansion. So just write the equations. When you write the equations here, neta is equal to 1 minus, now we are going to observe nRT1. So nRT1 log to the base E. So log to the base E, V2 divided by V1. So V2 divided by V1, again divided by, so divided by, there you are going to observe, sorry, nRT2. nRT2 log to the base E, there you are going to observe given by V3 divided by V4. So this is a isothermal compression. So isothermal compression. Thereafter nRT1. So nRT1 log E. So log to the base E. Next there we are going to observe V4 अथवा V1 divided by V4. So this is the equation. So when we observe finally, so these two will get cancelled here. So after making a cancellation terms, neta is equal to 1 minus T2 divided by T1. So this is also one of the terms what we observe efficiency of a Carnot engine in terms of a temperature, and this is the equation corresponding to what here, efficiency of a Carnot engine in terms of amount of heat energy provided and the amount of heat energy liberated. So amount of heat energy provided, that will be given by Q1, and the amount of heat energy liberated, that will be given by in terms of Q2. So ಎಷ್ಟು amount of heat energy provide ಮಾಡಿರಿ, ಎಷ್ಟು amount of heat energy liberate ಆಗಿದೆ, ಆ ಬೇಸ್ ಮೇಲೆ ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, efficiency ಆಫ್ ಅ ಕಾರ್ನೆಟ್ ಎಂಜಿನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಇಲ್ಲ ಅಂತಂದ್ರೆ ಬೇಸ್ಡ್ ಆನ್ ದ ಟೆಂಪರೇಚರ್. ಸೊ ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ನೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 minus T2 divided by T1. So this is the equation corresponding to what here? Efficiency of a Carnot engines.